Now we want to generate an equation using the data we have in graphical analysis. We're going to use our TI, but we need to change the data a little bit to make it match the formula that we have for our position. Now you can just use the data you have and your TI, you can stick in your TI and your TI will generate a quadratic equation. But if you just use the data the way it is, the A value you get and the B value and the C value will not have any special meaning. We'd like for this equation to look like this equation. So if I rewrite this and put the squared term first, I have 1/2. Now this is a different A. That should be t squared. 1/2 A t squared plus V naught t. I can write it this way. So that means what we need the C to be 0. If we can make the C 0, then the equation we get, the number in front of the x squared will be half our acceleration, and the number in front of the x will be our initial velocity, or the Mosel velocity in this case. So if I have this kind of data, if I have t and x and I have 5, 6, 7, 8, and this is 3, 4, 5, 6, I can say this is my starting point. If I make that my starting point and I say this position is 0, then that will make C 0, because C, if you think of it in terms of a graph, if I have a graph like this, this is your C value. So all I need to do is I just need to make the x 0 and start counting my time 0, and that will make my graph go through my origin, which means then the equation the calculator gives me will, the numbers in front, the coefficients in front of my x squared and my x will have special meaning. So all I have to do is subtract 5 from all these. So I'm just going to go 5 minus 5, 6 minus 5, 7 minus 5, and 8 minus 5. So I would get 0, 1, 2, 3. And then on this one I go 3 minus 3, 4 minus 3, so on and so forth. Now we've kind of done this before, and we can use our list. So what you'll do is you'll take your data that's in the time, you'll put that in L1. I'll take my Y data, put that in L2. And then I can use my list commands. So here's my calculator. I go to Stat, Edit. I already have some data in there. So L1 has my time data. L2 has my position data. Now you notice my position here is negative. Okay, so if you subtract a negative, that's the same as adding. So I have 40.2. So I'm going to get out of that, and I'm going to go second L1, or second one, and that gives me my L1. I'm going to subtract 40.2. I'm going to store, use your storage button, that in L3. Don't wipe out L2. So I do second 3, that gives me my L3, and enter. Now you see my first number is 0. Now I go back and I look at my data. I need to subtract negative 0.1266, so I'm going to add 1266. So I go second, and then I hit the 2 for L2, and then I add 0.1266. I'm adding because I'm subtracting a negative number with my data. So I store that in L4, sorry. If you do it correctly, you'll have a 0. If you don't have a 0 in the first part, then you messed up. Now I have data that I can use in L3 and L4. Now I can go to Stat, I can go to Calculate, and depending on your calculator, it may look a little different. I'm going to use, now this is the only time in this class we're going to use the quadratic, because we actually do want a quadratic. So I can scroll down, or I can choose number 5, and my t value is my x, so I put my L3 has my t value. I use my comma. I go L4, and then I'm going to go ahead and graph this. So I'm going to hit the VARS button, and again, some of the calculators, it's a little different than this, and I'm going to put it in Y1. Then I hit enter. There's my equation. That means my acceleration using this data, my data is not quite right. There's an error in my data, which I fix later. If I double this, that should be my acceleration is 12. So this number should be around 5, because our acceleration should be the acceleration due to gravity. This is my Mosel velocity, and it'll vary anywhere, depends on what click you're on, anywhere from probably around 3 in the 3s to the 5s. And this should be just about 0. And then you can go ahead and graph that, and you know how to graph the data.